So this is Dawei Lin. Actually, is the recording on?
It's being recorded.
Okay, thank you. So this is Dawei Lin. I'm the Associate Director for Bioinformatics at the DATE NIAID NIH. And I'm very happy to host this session with the distinguished panel of leading researchers in data commons. And welcome to the Bird of Feather session on data commons principles and practices. And welcome people in person in Seoul, South Korea, or join virtually worldwide. And so before we dive in, I have a couple of housekeeping items. The first is you please mute if you're not talking, and feel free to post questions in the chat throughout the presentation. We will pause for after each presentation for short clarification questions, and we will have a lot of time after all the presentation is done. And then we have a collaborative notes I post in the chat, and the Wim also posted again a Google Doc. A Google Doc is a RDA tradition for everybody to write the notes, and also at the very beginning of the notes, please sign in, put your name, affiliation, and the email so we can contact you. So so that is the logistics. If any questions so far? No? Okay. So then maybe we get into the session. I will start with the introduction. So I would just there's no slide. I would just talk through. So the aspirational principles has significantly impact the data science, technology, and community by unifying efforts to change culture and foster collaborations. The examples are FIRE principles on data to be machine readable, and like trust principles on repositories to provide long-term preservations, and care principles on community to be advocate for equitable use. And the data commons here we refer to, which is defined, I give the definition by one of the speakers you're going to hear about Grossman, is a resource with a governance structure and that allow a community to manage, access, analyze, and share data. So although there has been a significant investment and development in data commons in the past decade, and there's no such aspirational principles like I mentioned. So without such principles to help define a high-level architecture, we can imagine that data commons will form new silos, and more importantly, that they limited the potential of aligning the resources with expectations of the community. So this bird of feather is the first time that that we discuss on what is needed to develop aspirational principles for data commons. So we will touch upon the topics that what other community consensus on the core values of data commons, what other current challenges to realizing those values, and what other principles and compliance framework, and what other steps to engage with the community to develop aspirational principles. So the goal of the discussion is to assess if we are ready to develop overarching principles. And no matter the answer is yes or no, what is the next step? So I will chair this session, and Dr. Bob Grossman will lead the discussion on value and the lessons learned based on his experience of developing dozens of data commons. And Dr. Jill Bajo Sloan will lead the discussion on the growth, investment, and sustainability based on the experience of one of the most sophisticated and large-scale data commons in cancer research. It's called the Cancer Research Data Commons, and also short for CDRC, which has supported the researchers around the globe for many years. And Dr. Wim Hugel will lead the discussion on the principles and the compliance conceptual framework. And Dr. Andrew Traylor will lead the discussion on the global coordination on open research commons. And I should mention that there is a parallel session happening on global coordination of open research commons. And Andrew is one of the leader, but he's very graciously to join our session to stimulate the collaborations. So I will give the floor first to Dr. Bob Grossman. And Bob, please take away. Next slide, please.
It's a pleasure to be part of this virtual conference. And it's very much a pleasure to be part of this discussion that was just so well summarized. I'm going to talk about some lessons learned for about 10 minutes from my experience and of working with others, developing and building and operating data commons. Next slide. At the simplest level, you can think of a data commons as a software platform, a data platform that provides a resource for a particular research community. And there are those that add data, contribute data, and those that use data. And as just as we have software platforms such as Uber that pair drivers and users, this is a software platform that it allows certain groups to contribute data and certain users to use it. Our particular interest is in supporting research communities, and there's a platform sponsor who's responsible for the governance of the platform and the operation of the platform. Next slide. I'm going to talk about our experience with an open source platform called Gen3 that can be used to develop and operate data commons and data meshes. I'll discuss data meshes in a minute. We've, depending on how you count, operated over 15 to 20 of these. Each of them has a different sponsor. Each of them operates in a slightly different way. And our goal is to sort of support the sponsor and support the research community with a data commons or a data mesh that works best for them. Oftentimes there are other components in the mesh, such as computational resources or other sources of data or particular tools and services. Next slide. I think of a data mesh as one or more data commons together with computational resources and applications and perhaps knowledge bases that all can work together with a hybrid governance structure in which the glue the services that can be used to link the different platforms are operated with one governance, and then each of the platforms themselves, each of the commons has their own governance. So it's a hybrid governance model. We've built a data mesh in which we respect the commons governance, the data governance, and the consortium governance of each of the particular members of the mesh, and yet they can interoperate when they're allowed to do so. We have over 14.5 petabytes of data available in this mesh. There are over almost 1.5 million participants, and there are over 40 million objects, but each of them is governed with the particular governance of the commons or a platform that hosts the data. Next slide. This is a slightly more nuanced description of what happens. Here I've put the definition of a data commons or a data mesh. Data commons puts well curated data with a governance structure in a cloud computing or cloud-based platform with tools and services and applications to allow a research community to manage, share, and analyze data. Under the platform, it's like an iceberg in which all the hard work happens outside of those that contribute the data and use the data. There is the data governance, consortium governance, and commons governance. There's the data curation and harmonization. There's standards-based software services and applications. There's usually custom software development. There's security and compliance. There's the legal agreements, the liability management, and together this forms a commons, and a mesh is when there are one or more commons that support some type of interoperability. Next slide. One of my defining experiences was to build a data commons called the NCI Genomic Data Commons together with collaborators from the National Cancer Institute, the University of Chicago, Leidos Biomedical, and a number of others. The project started as we did a self-funded prototype in 2012. The project officially kicked off with a much larger scale, well, not with essentially somewhat larger scale prototype in project in 2014. It took us 2 years to curate the data and harmonize it and make all the data products. These days, we have over 60 to 80,000 users per month. We share each month over 2 petabytes of data with the users. And there've been dozens of high-profile papers that have been written using the data. We can analyze the entire data in the commons. There are over 80,000 subjects. We have whole genome and other data for them, and we can do these large-scale computations like you see on the right, where we did a pan-can analysis of all the data in the genomic data commons. This was a substantial effort, and a lot of my work has been asked, how can other projects build their own commons using lessons learned? And that's why we built the Gen 3 software. Next slide. I'm going to talk about some lessons learned from building these platforms. I won't be able to get to them I have a paper that you can find in archive shortly that describes 10 lessons. I'm just going to go over 4 of them given the limited time. the first lesson, and it's hard to overemphasize this. I think this is the most important. Oftentimes groups look at the success that some commons have had, and they want one for their own research community. And perhaps the most important lesson is successful commons are 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 focused on a specific research community that is tackling a specific set of research challenges, and build, and then the group gets together to build a platform that can be used by that research community for those challenges. Each research community is different, and you have to leverage the challenges and that community is faced with the right set of software and applications. It's tempting to split commons, by disease type or by data type or by institution or some other way. It's not that you can't do that, but most often you tend to get more of a repository than a commons, where you have a rich set of applications, a rich community, that the platform is well used. And so I think the most important thing is, understand your community's challenges and build something that meets them. Next slide. The second lesson is successful commons curate and harmonize the data. And here I'm using the terms that, for example, we tend to use in cancer and certain other areas where, there's the data comes in, the data is ingested into the platform, the data is cleaned, the data is aligned with respect to a particular data model, and then importantly, when data is processed by different groups using different pipelines, it could be hard to meaningfully bring together. And so it's important in many applications and in many domains to reanalyze the data from the raw data with a common set of bioinformatic pipelines, and you get data products. And so one of the important lessons is it's for data that's valuable to a community, it's usually economically more efficient for one group to curate, align, and harmonize the data. And then the economics of the data, even though this is expensive, the value to the community can be multiplied again and again. So the second lesson is successful commons tend to curate and harmonize the data, and successful commons tend to understand the economics of generating the data, curating and harmonizing the data, operating the platform, and building an attractive user interface to the platform. There's no right or wrong way to do this, but the curation harmonization is a very important process that makes commons successful. Next slide. It's tempting, and this has happened, to make a long set of requirements or put a long contract in place and just build a commons by requiring that you tick off those requirements. Commons like that tend not to age well, not to be successful. I think one of the lessons that we learned early on is you want a flexible architecture for your commons so that your commons can gracefully update and evolve over time. When we built our first commons, there were no Jupyter notebooks, but we built them over microservices with well-defined APIs. It was before there were standards. We've slowly, as standards were developed for processing data, say with GA4GH, we've adopted those. We've tried to push back on GA4GH when they haven't taken best practices from RDA. Sometimes we're successful, sometimes we're not. We've always built our commons with open interfaces. So as notebooks were developed, that was no problem because they could access data with our open interfaces. And When you needed new front ends or tools added, that again could be done. This is sometimes called the end-to-end design principle, or the end-to-end system design principle. It's how the internet was built. When you have a new protocol or new data type in the internet, you don't have to change all the routers because they're built over a common set of a small common set of protocols. And that's how we build our commons. It's how we build our meshes, which is why later we were able to create meshes out of the commons, because everything was open but tunable by the particular sponsor owner. So the third lesson is stay away from long list of requirements. Those commons tend to fail, sometimes fail disastrously, and have a flexible architecture that, if you can, follows the end-to-end design that was made famous for the internet. And here's the paper that describes that. Next slide. And finally, I think one of the challenges is the economics of data commons, data sharing, and accelerating research through data sharing is still not well understood. For example, we understand the cost of generating data, but it's much harder to quantify the cost of sharing data. One way to do that is to look at disability adjusted life years that are saved or generated by the data by the outputs, the research generated by the commons. But at a high level, you have the cost to generate the data, the cost to curate and harmonize the data, the cost to build and operate the data platform, and then the value is the near-term direct value from researchers using the platform, the longer term direct and indirect value when other platforms interoperate with your commons, and then the value, which is even harder to quantify, that is when you fulfill obligations to share data when you use public funds or philanthropic funds to fund research. And so I think one of the important challenges ahead of us is to better understand and better quantify the economics of data sharing through commons and related infrastructure. Next slide. So I view data commons and data meshes as sort of the evolution of how we manage data in science. We're familiar for the last 30 years of databases, which can organize data for a project, data warehouses, which can organize data for an organization. I think of data commons as supporting a research community or a particular research discipline. And finally, I think of data meshes, aka data ecosystems, as enabling discoveries with hybrid governance, in which you use mesh services that are follow the end-to-end design principle to glue together data across communities. Next slide. That's 4 of the 10 lessons. I'll share a paper with the entire 10 lessons, but I'm very much looking forward to the discussion in this session tonight.
Thanks, Bob. Any questions for Bob?
So I have a quick question, Darby.
Yeah.
So Bob, you talked, thank you, that was a fascinating presentation. You talked about the temptation to split commons by data types, and you said that most scientists actually want all of the data and all of the tools. I'm interested in your thoughts on connecting data commons together across quite different domains to solve some of the SDGs, Sustainable Development Goals, for instance. The examples you've given us are all in the medical space. How do you see this? Can you imagine a mesh that brings together social science data and geospatial data and health data, for instance?
I can, and the short answer is it's hard to build any of these. It's harder as you go across fields, but I think they're quite valuable. The first commons I built was for environmental science. I did that before we built our first biomedical one. We built one data, commons for data from NASA and data from the NOAA. These are two federal agencies that share geospatial data and environmental data in the US. For some of the comments that I've shown, we bring in a lot of social economic data that can be used to analyze it. So I don't think I don't think there's a simple short answer. Anytime you bring, and I don't mean to rule out splitting data for certain applications by data type. Sometimes this works quite well. The way I see things going over time is if we can lower the cost of creating commons and make it fairly easy through standard-based services for all sorts of data to be out there, then we can more creatively build commons for particular communities. Right now, it's a lot of work to build a commons, and sometimes they tend to look more like repositories. One of our goals is to build 200, is to make it so easy to build a commons, to have a commons as a service, so we can have a couple hundred commons over the next couple years with the Gen 3 technology. For some projects, we built 4 commons in a year for a particular projects, every 3 months. But the hard part is bringing the data together and bringing it together in a meaningful way, not the sort of just building the commons per se. So let me summarize by saying I gave a long answer to a short question, which means I probably haven't thought about it enough, but I think it's doable but hard.
Okay, thanks, Bob. So maybe let's move on. And Jill, you're next. The floor is yours.
Great. Thank you so much. Can I have the next slide, please? Oh, there's Bob. There's your acknowledgement slide.
Yeah, and go quick. These are background. Quick. It's Jill. Quick. Keep going. Keep going. There we go.
Oh, there we go. Thanks so much. So I want to thank Dawei and everyone involved with this meeting for having me today, and the rest of our panel. We're really excited to talk with you. I'm specifically going to talk about principles in investment, growth, and sustainability for data commons, with a specific bent and focused on the Cancer Research Data Commons, which is available through the National Cancer Institute in the United States. Overseen by the Center for Biomedical Informatics and IT, or CBIT. I do not have any conflicts of interest, but I am a full-time paid employee of the US government. Next slide, please. So when we think about a Cancer Research Data Commons, what sort of questions do we ask ourselves as to why we would do that? So we know that the NCI funds really valuable research that generates all kinds of data, basic science data, clinical trials, population level data. And many times it can be very difficult to find and analyze multiple different data types from multiple sources. And so a data commons can help organize them in a central place. In addition, most cancer researchers are not bioinformaticians or data scientists. And so their skill levels for data handling and data analysis varies. And so to have a data commons available that has easy to use, easy to interface with tools for analytics makes a lot of sense for broad-based use across all cancer research domains. In addition, data are often stored in separate data repositories where you have to go and download them in order to use them. Sometimes those data sets can be petabytes and petabytes of data, depending on what kind of data they are. And combining those data sets then with other data sets involves more downloads, the need for more space, the need for more compute power. And so I will tell you a little bit about how in the Cancer Research Data Commons, we have tried to solve those challenges. Next slide, please. So if we think about the scientific data life cycle, where the Cancer Research Data Commons comes in, and on the right-hand side is our pictorial view of the Cancer Research Data Commons, the various repositories that are available, our cloud resources, and some of the other interfaces that we have. It's really about data generation and collection, data submission, and data access is where we come in. Next slide. So just keep clicking because the little symbols, oh, perfect. So the Cancer Research Data Commons we see as the beginnings of a platform for a national cancer data ecosystem, where we're integrating cancer research across the continuum of surveillance, patient participation, discovery, and we're integrating in all of these different types of data that you see here that are highly relevant for us to have impact for individuals with cancer and their families. Next slide, please. Keep clicking, sorry. Okay, great. So our mission for the Cancer Research Data Commons is to empower researchers by providing access to a cancer data ecosystem where we have the ability for them to visualize, analyze, and interoperate between data sets in a flexible cloud-based computational environment. We want to preserve the long-term value of all of the NCI-funded data. We want to make it easy to submit data, access data, and interoperate between different data sets. And also, of course, the most important objective of all of this is to accelerate cancer research through the use of easy to interface with data sets so that you can analyze all different types of data together for maximal discovery. Next slide, please. So I don't want to go through this. It's a very busy slide, but I just wanted to show you on the top line are the different data repositories and sort of the timing of when they came online. And I'll go into each of the repositories a little bit in detail so that you can understand what's there. In addition, we have data infrastructure and analysis abilities that are available through the Cancer Research Data Commons. You can see that these two things are aligning together, which is really important to make sure that you're not just developing the repositories, but you're also developing the tools around them to make it easy to use and analyze for the cancer research community. Next slide, please. So we use what we call a data commons framework, or DCF. And it is a reusable, expandable framework that has very specific core principles and structures and is built on modular components, all in the cloud. It involves a centralized authentication and authorization, centralized indexing, as well as not just cloud storage, but also cloud compute, where we have relationships with Amazon and Google clouds. Next slide, please. So the three different cloud resources that we have available are available through the Institute for Systems Biology Cancer Gateway in the cloud, and that's based on Google, Broad's Fire Cloud, which is also based on Google, and the Seven Bridges Cancer Genomic Cloud based on Amazon. They each have their own sort of strengths and weaknesses in terms of what you can do very easily. And we hope that by offering these three available compute and analytic resources, that there's something for everybody to use that will suit their needs. You can bring your own data to analyze in collaboration with data that's available through the Cancer Research Data Commons. You can also bring your own tools and pipelines, but you can also leverage tools and pipelines that we already have available in the CRDC. Next slide, please. So just to delve a little bit into the current data repositories that are available, we have 5 with 1 coming online very soon. And so you've already heard Dr. Grossman talk about the Genomic Data Commons. That's our oldest standing repository. And that includes all sorts of harmonized genomic data with variant calls, standardized variant calls. There's the proteomic data commons, which involves harmonized proteomic, phosphoproteomic, lipidomic, and metabolomic data. There's the imaging data commons, which uses DICOM as their standard, but includes multimodal imaging data from multiple big NCI funded studies. There's the integrated canine data commons, which is very interesting. It includes information from the pre-medical cancer immunotherapy network canine trials. So these are immunotherapy trials in canines, where they also do comparative oncology with humans. And then we have the Cancer Data Service, which allows for all data types that may not be necessarily fit perfectly within the structure of the GDC, the PDC, the IDC, or the ICDC to be submitted and available through the Cancer Research Data Commons. And then coming very soon, the data is being moved into that repository is the Clinical Trials Data Commons. And it will start with data available from one of the hallmark NCI precision medicine trials called the MATCH trial, or the Molecular Analysis for Therapy Choice trial. Next slide, please. So just to give you an idea of how much data is sitting currently in the Cancer Research Data Commons, we maintain an inventory of over 3.5 petabytes. The majority of that resides in the Genomic Data Commons and the Cancer Data Service, and it mostly contains genomic file types. We are expected to grow our data inventory at an anticipated rate of 20% per year, which aligns with the projected bioinformatics industry growth of 15 to 19% annually. And so the graphics here show you a little bit on the left-hand side of how much data is available within each commons. It's important to keep in mind that the proteomic data commons and the imaging data commons have just more recently come online. And so those collections are growing rapidly and will continue to grow, as will the other collections. And then you can see for our cloud resources in terms of how much data is there, it's almost split between Amazon and Google. Next slide, please. So I think it's also really important to think about what are the sources of funding and to support something as large as the Cancer Research Data Commons. And so we receive funding through appropriated funds from the government, the US government, discretionary investments through the Center for Biomedical Informatics and IT, and also Cancer Moonshot commitments. And so you can see here sort of the breakdown by repository, infrastructure, service, and cloud resource, how those all play out. And you can see that it's fairly spread apart. But specifically, you can see that the CBIT discretionary funds are specifically used for the three cloud resources through 7 Bridges, ISB, and Broad. And that the repositories are split between the Cancer Moonshot and appropriated funds. Next slide, please. Just to give you a little bit of an idea, a snapshot on some statistics for the Cancer Research Data Commons, which I hope shows everybody what its impact has been so far, and we expect this to grow, of course. The Genomic Data Commons has over 65,000 users per month. It has almost 3 petabytes of data. About 2 petabytes of data are downloaded per month. You can see that the numbers are smaller for the other repositories, but these are growing at a very rapid pace. So for example, the Imaging Data Commons, or IDC, has 20 terabytes of data and over 400,000 imaging series available. For the NCI cloud resources, you can see that there's a large amount of data. All of the data that's in the Cancer Research Data Commons can be accessed through those cloud resources. But I think what's really amazing is that there's almost 2,000 publicly available tools and workflows available, and over 8,000 user-created workflows. So it's really a wonderful resource for those that are interested in having the ability to use the cloud resources that are available to analyze these data. So you don't have to worry about downloading the data yourself and having a place for them to be so you can analyze them. There are hundreds of publications that are using the components across the CRDC, and those continue to grow. every year. Next slide, please. In addition, the Cancer Research Data Commons is part of a larger data ecosystem that allows us to interoperate with other data ecosystems that are available in other parts of the NCI. So ANVIL is available through the National Institute for Genome Research and others that you can see here. And so this is really important so that we can make sure that we are able to analyze diverse data sets together for maximal impact. Next slide, please. So, I think it's important, however, even though this all sounds great, to make sure that expectations are set properly. And so what is the CRDC? It's a place to explore cancer data. We have genomics, proteomics, imaging, clinical trials, and in both human and canine. But what is it not? It's not going to be a place for every type of cancer data. And there are lots of other NIH repositories that are available that may be a better choice. And so we are starting to work very hard, talking with people across the NCI and also extramurally funded researchers about where is the best place for their data. So what are we really good at? We're really good at taking large data sets, such as the Cancer Genome Atlas, the Childhood Cancer Data Initiative. And what are we not going to be enabled to do? We're not going to be enabled to take the really, really small studies that have only a few individuals. They're probably more appropriate for one of the other NIH repositories that's available. Next slide, please. So we are embarking on a sustainability study. I think the Cancer Research Data Commons, as you can see, started 2014, 2015. And so enough time has passed, we've grown up, and it's time for us to think about what we want to do when we graduate from college. And so we really need to be thinking about how we provide the correct long-term support to sustain the Cancer Research Data Commons infrastructure. So we need to be thinking about data sets, we need to be thinking about repositories, we need to be thinking about the cloud-based analytics, and we need to be thinking about the infrastructure. And we need to be anticipating that we may need new mechanisms of funding. This could be, generated from multiple different sources. And so we are hoping to have a draft report in about a month, and we will be making, we have plans to make some of these recommendations for CRDC sustainability publicly available. Next slide, please. So what are our main goals moving forward? I think we really have three primary goals in addition to taking the sustainability study report and recommendations very seriously and trying to incorporate those into our plans. The first is lowering barriers to submission. So we want to make sure that data is as easy to submit as possible. And that would involve a single submission pipeline where we're able to accept all different data types. And we'll also have an automated de-identification pipeline for imaging, for the imaging data commons. We want to make sure that the Cancer Research Data Commons is usable and accessible to everyone, regardless of what their discipline is or their background. And so we want to make sure that we add to our arsenal of tools and cloud-based portals to make it easy for everyone to use it, regardless of what level you're at or what your discipline is. In addition, we must have a robust infrastructure. We need to try to make it as nimble and easy to change as possible, while making sure that we are respectful of all of the right security rules and that we have a comprehensive plan for long-term data storage as well. Next slide, please. So you can go to this website, datacommons.cancer.gov, and it provides you with a lot more information about each of the repositories, the cloud resources, a lot more about the Cancer Research Data Commons. This is definitely a team sport, so I have special thanks here to Tanya Davidson, Erica Kim, Manjula Kasaji, the whole Cancer Research Data Commons team, including both our federal employees and all of our contractors, and also the CBIT team, which includes federal employees and contractors. Next slide. And there's my email address. if you have questions and we aren't able to address them here, or you're watching the video later, please email me. I'd be happy to answer.
Yeah, thanks,
you.
Jill, for the very informative presentation. Any questions for Jill?
There's one I can see in the chat from Yuri Demchenko. I hope I pronounced that correctly. What services or tools do you use from the NCI cloud? Are there requirements to formalize the cloud? So you can get access. Anybody can apply to get access to one of the cloud resources. You can apply to get a small amount of free credits to sort of get you started in the cloud. And then you would be responsible for paying for charges moving forward. And those charges have to do with how much storage space you're using and how much compute power you're using. But there are many people who are able to do their analyses for their project just based on the free credits that they're able to get. So they don't have to pay additional money.
Jill, I have a question, like in terms of cost. I understand the infrastructure will need some support. You also mentioned that there is a lot of downloads, like 2 petabytes per, I feel like per day or per month, I forgot, but that's also a lot of money. So what is your thought on the sustaining support for that type of activities?
Well, so for the downloading, we've been able to cover that so far, right? But I don't think that that's sustainable for the future. And that's why we're, as part of the sustainability study, we're taking a really close look at each of the cloud resources that we have available and making sure that they are robust for anybody to use. There's a little bit of an activation energy that's needed, right, to go from using your high performance computing that you have available at your institution to then doing your computing in the cloud. But it's not as difficult as it sounds when you first talk to somebody. So I would really encourage folks to give it a try, especially because you can get some free credits to use it. And in terms of money, it costs a lot of money. You know, I think, oh yes, and Bob's putting in that that for the Genomic Data Commons, there's a private data center that's used and they do not have egress charges, and that this is common with public clouds. So we don't have egress charges either for the rest of the Cancer Research Data Commons. But I don't know, moving into the future, as the data sets start to grow and grow and grow and grow and grow, you know, is it going to always stay that way? In terms of sustainability, I think, you know, and cost, that's one of the main reasons why we're doing this sustainability study now, is I think we've gotten ourselves to a point where we really need to take a hard look at how we're spending the money and what we're spending the money on, and make sure we're spending it on the right things to bring the Cancer Research Data Commons into the future. But,
yeah.
you know, people don't think that these things cost a lot of money, but they do. So.
Right. Yeah, definitely. Okay, thanks, Jill. Next, we'll move to Wim. Wim, please take away.
Thanks, Dawei, and hello, everyone. Likewise, a pleasure to be involved in this session and presenting a slightly different perspective, what I would call compliance with rules of engagement or entry criteria. I'm the Chief Technology Officer at DANS in the Netherlands, and a long-time collaborator of Dawei in the Core Trust Seal. And a lot of what we'll be talking about today is born from that collaboration. Next slide, please. So we started developing the trust principles several years ago, and that, of course, is can be placed alongside the FAIR principles. FAIR largely focused on the expectations of the community in respect of data, and trust likewise focused on community expectations when it comes to repository infrastructure. And that is also complemented by CARE, which is in a way a placeholder for the equitable use of research outputs, both in terms of how it was created and how it is applied. So these are examples of what we call community expectations. And when we started talking within the broader group of collaborators in Core Trust Seal about the implications of open science aspirations for these sets of community expectations, we developed a representation that looks a little bit like a sandworm from Dune, but which tries to convey the idea that we move from principles through all kinds of frameworks for implementation, ultimately in some cases to sets of measures and metrics whereby compliance with the sets of criteria and the principles can be evaluated. And the challenge, of course, is that while this is reasonably well developed for data and data repositories, we also need to extend these ideas to other research outputs, such as code and semantic artifacts, and so on. And when we started looking more closely, we came across several challenges. The fact that there was a large number of unstructured assessments against sets of principles, that there was a lot of ambiguity in what things were called. So there was no real definition of what a principle or a criterion or a benchmark or a metric or an indicator of anything of these things were. Not all of these benchmarks, moreover, were focusing on the same level of detail or granularity. And we see the emergence already of multiple evaluation mechanisms and tools for the same sets of criteria. So these are some of the challenges that we are facing when we are trying to understand and potentially formalize the way in which all of these are conveyed to the community and how we measure compliance with sets of principles and criteria. Next slide, please. So we started developing a conceptual model that is too detailed, I guess, for a lot of discussion today, but trying to organize the things that we were encountering in conversations into four broad groupings, those of motivations, criteria, elaboration of those criteria, and then implementations that in one way or another try to benchmark or measure compliance with those criteria. What's important in a conceptual model towards the left-hand side is that there are various motivations for developing sets of principles and criteria. And we started out with community expectations such as fair and trust, but there are other sets of motivations for principles and their accompanying criteria. There are rules of engagement, there are sets of policies and principles, there might be characteristics of properly built digital systems and so on. So at the moment, we have identified 5 of these broad groupings of motivations that could lead to principles and then subsequently criteria and so on. And this is still work in progress, but together with Dawe and others, we're hoping to publish a paper about this in the near future. Next slide, please. So we're fairly advanced in terms of mapping Core Trust Seal and the trust principles onto this compliance network. And of course, FAIR is likely to follow. Next slide, please. So if we look at it from a slightly different perspective, at our opportunities that we have at the moment to create real working services based on the compliance framework, We are involved in dance in 2 projects. One is called Fair Core for EOSC, which has recently been funded by the European Union, and dance will participate and help to develop an implementation of the compliance framework that helps us to evaluate compliance with the PID policy that is applicable to EOSC. And that result will be operational in the next 3 years if the project is a success. And the formal name for it is the Compliance Assessment Toolkit, which will be a set of API services in EOSC. We're also investigating how to use the same framework for license and access conditions compliance. There's some very interesting work with a reference at the bottom that tries to automate very complex assessments of compliance in a graph-based mechanism. So that will suit our approach quite well, and we're looking at how to use encodings of licenses that are formalized in graph-like structures and to evaluate them against the characteristics of services or end users so that one can automate the evaluation of license and access condition compliance, for example. Next slide, please. We're also involved in another project called Fair Impact, where there is a strong focus on the tools and evaluation of FAIR. So in that project, we have an opportunity to map the FAIR principles and criteria onto the compliance framework to make sure that it is capable of accepting any anybody's perspective on how to measure and evaluate FAIR. And it's important to note that our compliance framework infrastructure is not prescriptive about how to measure compliance or how to even encode it, but it provides a consistent framework for people who wish to encode their frameworks, provide tools and mechanisms for evaluating compliance, and then recording information about it so that end users and services can discover everything that was recorded in respect of a data output research object or a repository for that matter. So I think our perspective in learning about data commons is that it will be very useful and interesting to see if we can map the rules of engagement or entry criteria such as it is available for the data commons effort to the compliance framework to see if it can be accommodated and how we should potentially extend it to make it more useful across the community. And of course, the secondary objective there would be to ensure that if the data commons overlaps with other frameworks for compliance measurement and encoding, such as FAIR and trust, that we reuse the same sets of encodings to the maximum possible extent. And that's it from me. So basically just an idea to a pebble thrown into the pond, so to speak, to see to what extent it's possible for us to integrate this work with what Data Commons has achieved to date. Thanks very much.
Thanks, Wim, again, and also especially thanks to present like 1 o'clock in the morning. So any question for Wim?
So I have a question, Dawe.
Yep, please.
Hi, Wim. Congratulations on your stamina. It's now 2:30 in the morning, so I'm even more impressed.
Yes, that's right.
Yeah, your conceptual model, is that now, I understand that some of the later derivative work is ongoing. Is the conceptual model essentially frozen, or are you also planning on updating or extending that over time?
We're certainly planning on extending and updating it over time. So it's, how shall I say, a first iteration of such a conceptual model. And largely, as I say, based on work that we have done in respect of trust and core trust seal, and to some extent already for FAIR, but we are now looking at other, let's say, policy-driven compliance extensions, licensing and access-based extensions. So very much a work in progress that will certainly iterate a few times before it becomes stable enough to use in a wider context, I would say.
Thanks.
Okay, we'll move the last presentation from Andrew. Please take away, Andrew.
Okay, thank you, Dawe, and my thanks to this group for allowing me to gate crash at the end and provide some different context. So we've seen two very impressive and specific sets of implementations of data commons for particular domains. We've seen a very high-level conceptual framework that I'm still wrapping my head around for how we might think about the interactions between commons. What I would now like to do is talk about the work of an RDA interest group and associated working group with the title of Global Open Research Commons. Next slide, please. So this is let me first start by talking about the interest group. So this is something that began at a BoF, like this BoF, in 2018. The interest group itself was approved in 2021. What we're trying to do is we're trying to come up with a shared understanding of what we mean when we talk about a commons in the research data space. Some of you may have heard the catch title that EOSC isn't, the European Open Science Cloud. It isn't just European, it isn't just open, it isn't just science, and it isn't really a cloud. The Global Open Research Commons is the opposite of that. We are global, we are focused just on open, we are focused just on research data, and we're interested in a commons in terms of Eleanor Ostrom's definition of commons. On the research data, I should make it clear that we're focused on not just data from research, but also data for research. So that is data that might be coming from other domains that would be relevant for researchers to use. So I'm thinking here of social media data perhaps, or data coming from government departments or even from industry. We're hoping to look outside the RDA community. So although we're an RDA group, we're not just looking internally. And the long-term goal is to come up with a roadmap for global alignment. What we'd like to do is try and make it easier for national and transnational commons initiatives to integrate together. And ideally, what we'd like to contribute towards is coordinating the delivery of a global open research commons. I should note, by the way, that because this is an interest group, we see this as potentially having a coordinating role across related activities in RDA that might be relevant. And I should note that there was a BoF yesterday looking at data spaces, which I also attended, which is it's another kind of overlapping circle in the Venn diagram. Next slide, please. So the definition that we're working with is global trusted ecosystem that provides seamless access to interoperable research outputs and services, which doesn't actually trip off the tongue. And so the tagline is digital research resources for the common good. And on the right-hand side, the brown box, I guess, you'll see that the NIH Data Commons that Jill talked about was one of the inspirations for the high-level model that we're pulling together, as well as the organization I work for, the Australian Research Data Commons, EOSC in Europe, the Canadian National Data Services Framework now being taken forward by the Digital Research Alliance of Canada, DRAC, and the World Data System and others. Next slide, please. So the first thing that we've come up with, and I should say I'm slightly embarrassed given the very impressive technical detail provided by by Bob and Jill that this is almost embarrassingly conceptual. So this is what we've called our typology of elements. So we spent quite a bit of time trying to think through what are the elements that you need to build up a commons, particularly a global open research commons. And we've identified, after a process that I won't bore you with, this set of common elements. The blue elements at the bottom are essentially the infrastructure elements. They're the hardware infrastructure that you need, they're the services and tools, and they're the research objects that you would store. Research objects, for those of you that haven't run into it, means all of the outputs of research. So not just the data, but the software and the publications and the models and the workflows. Sitting across the top, the white elements, or the elements with the white background, are, if you like, the more social aspects of a commons. So the people, the rules of participation, this is a term we stole from EOSC, the governance structures that you need to make the commons work, how you engage with your users, and as Jill pointed out at the end of her talk, the need to come up with a sustainability plan to ensure that you can continue to deliver the services your users are reliant on. And in the middle, placed there deliberately because of its centrality, is the importance of interoperability and standards. So the interest group spent some time developing this, and we thought we could kind of sit back and rest and relax until someone said, well, wait a minute, what do you mean when you say engagement? So next slide, please. And so now what we've realized is, well, we actually now have to define all of those terms so that we're all talking about the same thing. And so that's a collaborative work in progress. The document that we're using to develop that, there's a link there, which of course is not going to be a lot of use to any of you. When I finish this presentation, I'll post the link to the definitions document in chat if anyone wants to join in and help us define them. We're aiming to converge on a set of definitions within the next couple of months. We're kind of most of the way along that path. So at the end of that, we'll then have both a set of elements and a set of agreed definitions for those elements. Next slide, please. Thanks. So that's the interest group. We also have an associated working group. So this is the International Model Working Group. It's not a great name, I have to say. So this was approved in 2021. And this is saying, okay, the interest group's coming up with this high-level conceptual framework. What are people actually doing? What are people doing within their national, pan-national, and domain, commons domain, in this case being research domain? And here we're looking at the kind of the internal aspects of those commons, particularly how they measure user engagement or content generation. And we're looking at the external elements, the types of services and structures. And so we're using that high-level typology model as an organizing principle. And essentially what we're doing is we're working through a series of case studies looking at particular commons implementations to capture them as exemplars of commons features, if you like, where you can think of it as stress testing the conceptual model by comparing it to what people are actually building. The output of this is going to be essentially an analysis document looking at a series of commons and then abstracting from that the elements that make commons work. So it's not quite the same as the principles for data commons. It's more a landscape analysis of what's going on. And of course, anyone is welcome to join the meetings. We meet monthly. We have a rolling notes document so people can go back and see what's happened in the past. And the interest group and the working group, both of those sessions, well, both of those groups are presenting in a session later today, at least later today, my time, later today in Korea, in the afternoon. And although the timing is terrible for Europe and not great for the US, you're welcome to join that meeting as well. Thanks, Dawei.
Yeah, thanks, Andrew. Any questions for Andrew? So Andrew, I have one for the high-level framework you guys are developing. What are the audiences you're thinking that you're targeting?
So that is a great question, Dawei. And perhaps if whoever's driving the slides can go back to slide 46, please. Sorry, I'm pausing because we've never asked that question. I guess in my mind, the audience would be people who are seeking to set up a commons. At the first point, should be made aware that they should not just focus on the technical aspects, but they need to be aware of all of the social aspects as well. And part of what we're hoping to get out of our landscape analysis work is essentially a checklist for each of those elements. So for each of the human capacity, rules of participation, governance structures, engagement, sustainability, what are the elements that you should be thinking about? Or alternatively, what are resources that you should be looking at? And clearly some of those, I mean, any one of those individually could be huge, so sustainability, there are lots and lots of things one could say about different sustainability models. And so maybe what we might do there is point to examples of sustainability models that works. I note that Mark Parsons has just joined us. Hey, Mark, and has asked whether commons was ever defined. I'm assuming, Mark, you mean for the purposes of this discussion. No, we didn't define it. We just dived straight in. For the slides I've just given, we're using Ellen Ostrom's definition of commons.
Thanks. Is that a common definition? I think that's a great definition, but does EOSC use that definition?
Well, EOS doesn't talk about a commons, so EOS
oh, right, it's cloud. Sorry,
it's cloud,
sorry.
Yeah.
But there are many commons. Is there a common commons?
Oh, please. There are, as you say, many commons. I will allow my co-presenters to say what definition they're using for commons, and I'll put the link to Ellen Ostrom in chat.
Yeah,
as well.
I saw William's hands up. Do you want to respond to Mark's question?
Not directly on the definition of commons, but shall we dare to say a common problem in terms of what I'm starting to call communication interoperability. In EOSC, we have probably about 20 task forces that are helping to define the architecture and the specifications for common implementation. But even amongst those task forces, it seems an impossible task to agree just on how to describe those architectures and specifications and at what levels of granularity they should be described, because you often find documentation from two task forces that are completely incompatible because of lack of shared definition of how to communicate things. So this might be an interesting side issue to pursue in RDA, is how do we, and I mean the compliance graph work is to some extent a subset of that, is how to be more precise in the things that we describe and try to communicate.
Yeah, I think that Mark's question also a great segue to have a larger discussion. And I think the idea to propose this session to develop high level or aspirational principles is to not focus on details, and it's trying to propose something that everybody can understand. That everybody means founders, the technical managers and users. They all understand the importance of data commons. Not just about definition. Like what is like core value? Why you want to exist? I think that's kind of the question. And I know like a lot of people may not participate the whole session. I think I saw like the notes has the collaborator note has a lot of information there already. Although it is the first type of this type of discussion on comments, and I think that the Bob gave a very a useful lesson learned. There was 4 of them, and then the Jill present a really use case, and I personally just check the lesson learned, use lesson learned to check the cancer data comments. I feel like I check all the list. Like the cancer data comments have the specific community and tackle a specific set of challenges, and is curated and harmonized, and then the architecture is flexible. It's kind of evolved for 10 years and is working well and empower a lot of researchers. And still, I think Jill mentioned about the sustainability study is a challenge to understand the cost. So so that type of survey is interesting. And then the WIM, I think, to really address on the principle definitions and principles. I like to use Reed Delo's definition is a smart solutions to some occasions that happen over and over again. So I think Bob built a lot of data commons, and now we have a successful cases for CRDC, and so that means there is a lot of reoccurring solutions there that may be helpful. So that I feel like it is a time maybe we can think about, like what are those key solutions that no matter the national commons or organizational commons, or maybe even the research lab commons, if as Bob mentioned, if like the cost is low enough, that we can, so that those principles may guide all different kinds of commons work together. And I think Angel talk about this the RDA working group is, they already think ahead, and this type of discussions is already a year and more old. But I think the things what probably I kind of open the floor is that so what people think about the core values, like in the simple terms, I think like is a community that the data commons enabled, or it is the flexibility of the infrastructures, or is the interoperabilities of the data objects within the commons. So what people think about your core values when you think about data commons?
I think of it fairly simply is the ability to accelerate research for a particular research community. And that begs a number of questions of how do you measure that? How do you measure the cost effectiveness of that, et cetera? But one basic value, it's important if it could, make it faster for people to do research than they would do otherwise, because either, for example, someone has done the basic curation, someone has put the tools close to the data, someone makes it easy to bring in other data that's needed. But the ability to accelerate research for a particular community, I think, is an aspect of a commons.
Okay. Yes. So that sounds like the social aspects that Andrew mentioned, that the community needs is something like data commons are should pay attention to. So Andrew, like your hands up.
Yeah, thanks. If I can just agree with Bob and kind of take it a little bit further. So I agree that none of us want to build commons just for their own sake or because they're fun. We're building them to achieve an end. The way that we've talked about it in the work we're doing in Australia, at least, is we haven't talked about it just in terms of acceleration. We've talked about it in terms of transformation. So what we want to build commons, thematic research data commons is what we're calling the things we're currently building. We want to build these thematic research data commons that allow two kinds of transformation in the research, two sort of step changes. The first is transformation in speed of research. So this is what Bob's saying, that you're able to do things more quickly. You know, a PhD student can now do something that would have taken a team of 5. But that's not the only kind of transformation. As well as a transformation in speed, we also want to bring about a transformation in kind. That is the ability to do research that you could never do before by bringing together data from different places or different domains to answer some of these SDG goals. So for me, it's not just about transformation in speed, it's also transformation in kind.
Mm-hmm. That's interesting. So any technical aspect of the core values that data commons can bring in?
I think it's important to remember that this is the basis of the genomic data commons that Jill and I talked about. Is commons can reduce costs in dramatic ways for the sponsors. You know, a lot of cancer genomics involves, analyzing data at the petabyte scale. If each research group had to be separately funded to do that, it would just be cost prohibitive. So an important role for commons is reducing the overall cost of research for a community by, for example, centralizing those resources, like the data and the harmonization and the curation that makes sense to centralize, and yet allowing local distributed research when it makes sense, for example, through notebooks or other types of applications. But the ability to lower and make research more efficient is another aspect.
Mm-hmm. Yeah, I saw the organizer wanted us to end like 5 minutes early, so we have maybe one more comment from somebody. So I guess Andrew, I think that for the working group that you're involved in, what are your suggestions that how can we continue the discussion there, or maybe we should do another different ways of doing further this discussion?
Yes, that's a good question, Dawe. I think certainly we should be inviting Jill and Bob to present to the working group on their commons and the work they're doing to make sure that informs our thinking. The question of how to take the principles forward, I don't have an immediate answer for you. I'm sorry. I'm not saying it's not possible. I can't think of the best way of doing it. So perhaps if you allow me to take that back to my co-chairs, and we'll discuss that in our kind of wrap up at the end of this plenary, and we'll get back to you. Is that okay?
Sounds great. Okay. Yeah, so
and
our time is up.
thank you again for the opportunity to talk to you.
Oh, definitely. Yeah. Thanks all the speakers today, and also the people participate virtually and in person. Have a good rest of the RDA. Bye.
Thank you, Dawei.
Thank you. Bye-bye.
Thanks, Bob.